Welcome to another session of AgOtter software discussion. Today we're going to be talking about the advanced setup. So in the upper right hand corner, you'll notice that's where we get into the setup. In the upper right, I press setup, and then in the upper right, it's advanced setup. So going into the advanced setup, we're going to talk about, this will be part one of the advanced section. Today we'll just talk through the first several options, and when we do part two, we'll talk about the options at the bottom. But here we're just going to talk about the first three options. So starting with flow measurement, this is where you pick if you're using 2 meters or 1 meter. In this case, we're using 2 meters. Most cases we do that. We're reading a left and a right. Of course, you can just use 1 meter. If you change it to 1 meter, that's going to switch over to just the 1 meter calibration number. Switch it back to 2 and you'll see 2 a left and a right for the calibration number. These calibration numbers are pulled off the side of the meter, so you'll see typically with the electromagnetic meters that we use, you'll see pulses per gallon, or it says PUL/GAL, pulses per gallon. Of course, that's when we're in US units. When you're in metric, use pulses per liter. Here we see it just says ppg. Pull that number straight off the side, and what that is how many signals are sent per gallon of fluid that goes through it. So there's electromagnetic pulses that come through. So you'll see that reading. Let's say that reading is 1164. You just type in 1164, and typically if your left is 1164, your right will be. They could be different, but that would be very unusual. They would typically always be the same, and because they would be the same size meters on your left and on your right. And this will give us a distinct difference between what's happening on the left and what's happening on the right. And we always, almost with 100% of our installs, we do notice some difference between that left and the right. All else equal, there's just some reason. Typically it's nozzles, could be filters, could be plumbing, could be other issues, but typically nozzle wear and tear is the culprit. And we see anything from just a couple percent difference to over 20%, 25% difference is not uncommon to see that on a side to side variation. And that just tells us we really got issues with the one side, and typically it tells us we got issues with the nozzles. Again, could be other things, but 99 times out of 100 it's going to be nozzle issues. The next thing down from that is speed measurement, and this is just reading from a wheel sensor. So one thing that's special to AgOtter is we have we do some things to augment the GPS, so you're not reliant on only GPS for your latitudes and longitudes. We have a patent written, so we can actually, if we lose GPS in the field, we use an inertial system, an onboard inertial system that gives us the side-to-side motion, and we use a ground speed sensor to give us the forward motion. So that way we can extrapolate latitudes and longitudes without having GPS. So you can lose GPS in a field 100 times, you're never going to know the difference because the inertial system and the ground speed sensor will always paint a pretty picture. It'll paint over the imagery, always give you a latitude and longitude. It'll keep your rate. You'll never know that you lost GPS. So that's something that's unique to AgOtter and what makes us so special in working in orchards and vineyards, things that block out GPS. If you turn that off, you're just running off GPS. So it's just using GPS speed. If you don't need to use a ground wheel sensor, you don't have a lot of obstacles in the sky, really no reason to use a speed sensor. You don't even need to install one. You can just go off the GPS. But using a wheel sensor, even when you're traveling at slow speeds, a wheel sensor is actually more accurate than GPS, especially when you start getting down to about 2 miles an hour. GPS just doesn't like that speed. There's too much variation at slow speeds. Wheel sensors are a great high precision instrument at slow speeds. So that's another reason where wheel sensors are favored over GPS for things in agriculture and slow speeds. But anyway, having your wheel sensor enabled, then you enter a tire circumference and the number of wheel bolts. So the tire circumference, how you get that is just mark the tire, let it mark the tire in the dirt and let it do one full revolution, and then you'll measure the distance from one spot to the next. and that gives you your tire circumference, number of bolts. The wheel sensor is going to be put on the back side of the wheel, so it's just reading the bolts as they pass by. So it just wants to know, okay, how many bolts did it see in that one revolution? So every 113 inches, it sees 8 wheel bolts. So it knows that's a revolution, and it knows that went around once. So that's speed measurement. The next item here is valve control. Valve control has an aggressiveness, so that's just telling us, how aggressive do we want to move that control valve to get control. And just a good rule of thumb, a good number to start here is like a 2.0. So I'm just going to say 2.0, and that's going to be what we're going to start with. And a good rule of thumb is if that is fluctuating a lot, if it's, you're shooting for 100 gallons an acre and it's going 110, 90, 110, 90, 110, that's too aggressive. It's moving too much. It's searching. You want to dial it back. You can go as low as 0. We don't advise that. The lowest we typically would go is about 1.0, and a good value to start with is 2.0, and you might want to bump it up to 3.0. Really, that's the wheelhouse. You can go outside those ranges, but they're not typical. And if it's not aggressive enough, what you typically see is that it will just kind of give up. If you're going for 100 gallons an acre and it gets to 85, 90, and it just doesn't move any further, and the valve's not all the way open, well, it's quitting. It's not aggressive enough. Or if it's coming down from the top side, it's going to 100 and it gets to 110 and 105, and it just never gets to 100. That's not aggressive enough. So boost that number up. The last item in the part 1 of the advanced settings is valve return to tank. Now that is just a switch. It's turned on or off, and it reverses the logic of the system. If your control valve is set up on the return to tank side, so it's on the return side, you would have that on, or that would be green. And if you have your control valve set up on the inline side, you'd shut that off. That would be clear. And that's very important setting because that really controls how your entire system is set up. It reverses the logic. So if your control valve is on the inline side, meaning the valve is opening to let more through to the nozzles, and it closes to restrict the flow through the nozzles, that's on the inline side. That you want off. If it's on the return to tank side, meaning you want to actually close the valve to force more through the system, and you want to open the valve to redirect flow from the nozzles back to the tank to flow less, then you'd have that on. So it's very important to have that correct, because if you have that backwards, the entire system will work backwards and will open instead of close and close instead of open. So it's very important that you set that up properly. So that'll be it for the first part of this advanced. In the next section, we'll talk about all the options at the bottom.